We now know that there's neurogenesis going on all the time. But a lot of people don't really understand that. I think it's pointed out if somebody has an injury that it's been shown that you can actually, regenerate a part of a damaged brain. Talk to us about that and what kind of implications that has for all the rest of us, that if we just did the cardiovascular work, et cetera, that we could also get that kind of neurogenesis going on.
Right. I think the neurogenesis thing, you don't want to oversell it. And here's part of it. So there was a great controversy in the field for quite some number of decades about whether this was possible at all in adults. Now, we know this is possible in youngsters, and no surprise, right? You have a lot of neurogenesis in a fetus and so on, and through early life. And in fact, we're born with many, many more neurons than we're going to go through our life with. So actually up until the age of 2, we have billions and billions of neurons. And then we lose a lot of those neurons, part of what's called neural pruning. When that goes awry, sometimes actually that may be part of what happens in the autism spectrum. And we all lose neurons because the ones that we're using are wiring together. So this is a sort of what wires together, fires together to create the networks that give us our good cognitive health and our intellectual outcomes. And we're losing neurons all the time. And then, of course, across the lifespan as well, we lose neurons, often to disease and to other issues like that. But one of the things about the remaining neurons is that if we're using them well, they have the ability to connect up in new and novel ways, what we call neurite outgrowth. So that's a form of neurogenesis that doesn't involve new neurons showing up.
Okay.
Now, the other piece is a little bit controversial, and that is that there's evidence, particularly in animal studies, for neurogenesis in adults. And whether that's really occurring in adult human beings is a little bit controversial. We suspect it is, but we don't know that the small number of neurons that are occurring in that way are really having a huge functional impact. And then the last thing I would say about that is, of course, that we now have technologies and techniques with stem cells and pluripotent stem cells to potentially add cells in and grow new neurons in a brain. This is already happening in animal studies, and it looks very promising for humans, but that's the future.
So as you get older, for those people who become very isolated, they live alone, they're not socializing, they're not talking with people, they're not having to use their brains, is that the kind of thing you're talking about, that if we just keep using them well, that we can create more connections?
There's no question that one of the biggest risk factors is social isolation. So obviously all these other health decisions that we make, cardiovascular health, they're major players, but a big chunk of what we call the variance is also accounted for by our social networks.